Hey guys, we're back. And now we're talking about systems of linear equations in two variables and the elimination method. And I'm sure that you're feeling like there's so many variables, but for now, what's nice is that there's just two variables, which means that once you solve for one, you just have to plug it back in and solve for the other, which is really nice. We will get to the point where we'll do some three variable and even more variable equations after this, but take heart. We're going to, hopefully this is not new for you. We're just really dialing down some of these methodologies. And this past section, we learned about graphing and substitution. Now we're talking about elimination again. So if we're defining the method of elimination, we know the method of elimination is using multiplication to obtain coefficients that differ only by their sign, so that by adding the equations will eliminate a variable. Or I should say, a variable is eliminated. Okay. And now if we're talking about equivalent systems are just two systems that have the same solution set. So it makes sense. And a consistent system is a system of equations, so abbreviated EQS, equations with at least one solution. This could also mean many more than one. It could also mean infinity. Okay? And then an inconsistent system is simply a system of equations with no solution. Okay, so we dialed in some of the vocabulary. Now let's start to break down some of the methods. So the method of elimination, we're going to list the steps necessary. So step number 1, we're going to use multiplication so that, well, I should say, we're going to use multiplication to one or both equations to get the coefficients on one variable to be opposite. And opposite means if one coefficient is a +4, the other one's a -4, and vice versa. Step 2 is you're going to add them to eliminate, and then solve the resulting variable. And then lastly, you're going to substitute back, or back substitute, which we talked about last section, to solve for the remaining equation. And just like before, you always want to make sure that when you're done, you plug it back in and check it. So the operations that can be performed on a linear system are three things. We can interchange any two equations. We can multiply an equation. That's by a non-zero. So you cannot multiply by 0, but you can multiply by any other real number. By a non-zero constant, that is. We can't multiply by a variable. And then lastly, we can add a multiple of one equation, aka multiplying, to any other equation of the system. Okay, so let's kind of jump into a little bit of this. So if we're talking about strategy, so this example right here says describe a strategy for solving the system of linear equations. Yes, strategy, right? So if I'm using elimination, first I want to decide, okay, which variable am I going to make sure that the coefficients are similar? And to me, these y's look like they're going to be the easiest to multiply, because if I want to make the y's the same, I would just need to multiply the top equation, multiply it by a 2. And what that would do, that would give me a 2y, while the bottom one has a negative 2y. And we know we're looking for the same coefficient with opposite signs. So what I would do is, describing it, I would multiply the first equation by 2 so that the y terms are eliminated when being added. Okay, so that's just knowing kind of like the first step of elimination. So let's go ahead and do one for an example. We're going to solve the system of linear equations using the method of elimination. So one thing I like to do first is kind of look at it and say, okay, what am I going to be doing here? So honestly, this one can go either way. I could multiply the top one by 3 to get this to be 3y, and then this would be a negative 3y down here. I also see that on the x's, this is a 4x, and this is an x. So honestly, it's equally easy to either choose x or y. I'm going to go ahead and just choose, I'm going to choose to eliminate y. So what I'm going to do here first, if I'm going to choose to eliminate y, that means I have to multiply the top one by 3. So I'm going to rewrite this, and I'm going to distribute the 3 to every single part. We end up with 12x plus 3y equals negative 9. Do not forget to multiply that 3 to every single part, including what it's equal to. And then we're just going to move this one over. X minus 3y equals 9. Now, because we now have those same coefficients that only differ by a sign, now we're going to take these and add the equations on top of each other. So now 12x plus 1x is 13x. 3y minus 3y cancel out. That's meaning eliminated, right? They're like terminated, right? And then negative 9 plus 9 is 0. And now all we have to do is solve this. We're going to divide by 13. And we get x equals 0. Once we have that, we're going to plug it back into, or back substitute into one of the original ones. I'm just going to plug it into right here. So I end up with x, which is 0, minus 3y equals 9. So negative 3y equals 9. If I divide both parts by negative 3, we get y equals negative 3. So my answer is the ordered pair. Remember, it always goes in alphabetical order. X comma y is 0 comma negative 3. And there is our solution by elimination. Okay, so what if we're talking about graphical interpretations of what's going on? What do we call that? How do we explain that? So a system of linear equations, if it has two different solutions, it also must have an infinite number of solutions. And here's why. If they're linear, think about it. If this is my graph and I've got one line, the only way to make another line have two solutions with the line I just gave is if it literally intersects it more than once. Means basically it means it's the same line, which means it has to have not just two, but an infinite number of solutions together. Okay, so for a system of two linear equations and two variables, list the possible numbers of solutions that you can have. Well, there's three possibilities. Number one is there's just exactly one solution. Okay, and that means that the two lines intersect. So when there's exactly one, if this is my graph, here's one linear equation and here's another, where we can see that the intersection happens right here in the middle, exactly one solution. Let's look at the next one. The second one is infinitely many, which we kind of talked about that just now. But in order for them to have infinitely many solutions, we'll have a line and another line that has basically it's the exact same line, and it basically covers all of the same exact solutions as that one. And then the third way is that there's no solution. And the way that there could be no solution is if when we're graphing them, they're parallel. So if here's one line, it will never intersect with another line that's parallel. Okay? So basically, no solution happens when the lines are parallel. Okay, so let's say you're solving through something, maybe you're using elimination, and there's a false statement, such as 9 equals 0, which of course it's not, right? When we get down to the bottom of it. When we're using elimination, this can happen, and we say if this is our last statement, 9 equals 0, we know that can't be true, so we say this has no solution. Okay? If a statement that is true for all variables of the statements, like 0 equals 0, which is true, or 9 equals 9, or some version of that, we say the system has infinitely many solutions. Okay? Okay, so then now let's talk about, is the following system consistent or inconsistent? Keep in mind we had this in our first box of vocabulary words. Remember, consistent meant that it had at least one solution. Inconsistent means that it has none. So in order to do this, we're going to use elimination to start to solve. Okay, so basically consistent or inconsistent is it's a determination once we've seen whether or not it has a solution. So in order to solve this, I can recognize that it's going to be really easy to get this x right here to look like this negative 4x, okay? So I'm going to multiply the top one by 4. I'm going to move it over here. So when I multiply the top one by 4, I get 4x minus 12y equals 8. And I'm just going to list this one right underneath it without changing it at all, because now I've got what I need it to look like. I'm going to add them. And we know 4x minus 4x eliminate each other. 12y plus 12y also eliminate with each other. So on the left side of the equation, we end up with 0. And then 8 plus 8 here is 16. So we know that is not a true statement. 0 cannot be 16. So we know that there is no solution. And by our vocabulary, we know that this is inconsistent. Okay? All right, that's it for now, and I'll see you back in class.